Okay, the equation for the confidence interval of the mean when we're dealing with a single sample size is z x bar plus or minus z alpha over 2 times the standard error of s over square root of n. And that's equation 7.8 in Devour. So if we're dealing with that as a confidence interval, the problem is that will always give us a confidence interval. But what if the confidence interval isn't what we expect or isn't what we want? Sometimes what we want is a particular width. We want to know plus or minus x, exactly how things are going to go. So to get that kind of an answer in a problem, which in our case is problem 7-13 in our text, it's number 4 on the most recent homework assignment, I believe. We have to convert this equation so we can talk in terms of the width of the curve. So we want to know the width, so we'll treat that as W. Okay, it was a plus and minus on the original equation, so it's going to be twice whatever number we get from this basic derivation here. So it's 2 times z alpha over 2 times s over square root of n. So the width of the interval can be calculated using the same formula we got in 7.8, only now we're treating the width itself as the variable of interest, and we want to know roughly how to get back to a sample size that would give us that width. So we can do some very basic algebra. We decide, multiply both sides by square root of n, divide both sides by w over 2 times s over w. So there we've converted the formula into one that looks for n. We can square both sides to say the n that we're after is 2 times z alpha over 2 times s over w, and take that quantity squared. So that's the formula we can derive very quickly from 7.8 to determine exactly what we're looking for. So let's assume that we're doing one of our problems and we're told that we want to know if we think the standard standard deviation is 174, and we'd like to have a width of 45 on our confidence interval at a confidence of 95%. So we're going to use a z of 1.96. So given that basic range of parameters over here and plugging that into the values, we would get n is equal to 2 times 1.96 times the 174 divided by the width that we want, 45, and we could square all of that. Plug that into your calculator and you get n equals 229.745. Your decimal places will vary a little bit depending upon whether you're actually using 1.96 or you're using the norms function in Excel, which gives you a lot more decimal places and precision. So it might lower that number a little bit. We're not too concerned with that basic number because we don't really care what the decimals are. Whatever they are, we have to round up. We can't have a sample size of 229.7. So the sample size we need is 230. So if we want a 95% confidence that we'll have a width on our confidence interval of 45, we have to go out and take a sample of 230 in order for it to work out to the appropriate width in our sample size. And that assumes that we're making a pretty good guess, because this number right here is actually a guess before we do the experiment. So you have to know something about your data. The more you know, the more reliable you'll be. But you want to use a sample size here of 230.